This video is going to look at your parent functions, and what we're going to look at is the 8 common functions that we're going to look at that you should become familiar with and know the graph of each one of these. And the first one we're going to look at is our constant function. F of x equals c, and if this is our constant function, then that simply means that if we have f of x equals just a number. F of x equals 2, so therefore it remains constant. In other words, f of x, remember, that's our y, so in other words, that means our y value is always 2, so a constant function is going to always be a horizontal line. Our next function, f of x equals x, is the identity function. An example of this would be if we had the equation, let's say y equals x. And in this case, what this means as far as the identity, if x is equal to 1, then that means y is equal to 1. If x is equal to 2, y is equal to 2. So that means you're going to end up with a diagonal straight line that goes right through the origin. And it's the identity because whatever x is, y is the same number. So that is f of x equals x. Our next function, f of x, equals the absolute value of x. So here we have our absolute value function. And it's denoted by the 2 vertical bars. And if we look at the graph of your absolute value function, it is very distinctive. It always has a sharp V shape. Okay. And this V shape, of course, could open up or could open down. This is your absolute value function. And the one that most of you are probably familiar with is f of x equals x squared. This is your quadratic function. And of course, the graph of your quadratic function is a parabola. And then this is more of a U-shaped, okay? So this is different from the absolute value where this has a smooth curve, whereas the absolute value is going to always have this sharp corner like a V. All right, the next function is f of x equals x cubed. This is our cubic function. And this function is going to look something like this. It's kind of like a line that has a little bend in the middle here. Almost kind of looks like a chair a little bit. So there's the graph of our cubic function. And then next we have f of x equals the square root of x. This is the square root function. And the square root function, this should be a little bit obvious possibly. Remember the square root, we cannot take the square root of anything less than 0, so that means your x values have to be anything from 0 to infinity. So really this is going to look like basically half of a parabola on the side. So you're not going to have anything over here to the left, you just get this kind of top part of the curve. Now, as we go through these parent functions, these are the basic shapes, and in a couple more videos, we'll look at how we can actually move these functions around. All right, we have f of x then equals 1 over x, and this is the reciprocal function. And here we should realize the domain. We know that if we have 0 in the denominator, it's undefined. So if you have 1 over x, then that means x cannot be equal to 0. And the graph of your reciprocal function is going to look something like this, where your graph splits at the origin. And here your graph is going to ever get so close to the x-axis as it goes to the left and as it goes to the right. And as the graph goes here up and down, it's going to get extremely close to the y-axis, but it never will touch the x or y-axis. So keep that in mind. Sometimes if you put this in the calculator, it looks like the graph touches the y-axis or the x-axis, but realize it's impossible for this function to be equal to 0, because the only way this could be 0 is if you have 0 over a number and the numerator is always 1. So that's why we have this kind of split in the graph here. All right, then our last function, this may be new to some of you. You don't see this one a whole lot, but it does have some applications. F of x equals, and you have kind of a little double bracket here. And this is called the greatest integer function. And f of x equals this little symbol here, your greatest integer function. And let's kind of review really quick here. If we're talking about your integers, what are the integers? Well, the integers are such as -3, -1, oops, -3, see if I learn how to count here, -3, -2, -1, 0, 1, 2, 3, and so on. So your integers here or what you would kind of call your whole numbers, plus we're looking at the negative of those numbers, but realize we're not looking at decimals or fractions. So we're strictly looking at 0, 1, 2, 3, 4, 5, 6, 7, and so on, or -1, -2, -3, -4, and all the way to infinity. Now how this works is that when you plug a number in for x, well, let me go ahead and show you the graph of this function first. And this is called your greatest integer function, and it's also referred to as a step function. And if you look at the graph, you will certainly understand why it's called a step function. And the graph is going to look like this. We have a solid dot here at the origin, and then it goes all the way to 1 with an open circle, and then it jumps up here to 1 unit at 1 and continues until we get to 2, and then it's going to kind of repeat this pattern. So then if we were at -1 here, we'd have a solid dot all the way over, open circle here, and then if we were down at -2, we'd have a closed circle, and then we would go over and have an open circle. So remember, the solid dot represents that's equal to that value. Open circle means it's very close, but it's not including that value. So for example, if we were given the following, if we wanted to find f of 0, which means we're looking at, and I want to point this out, sometimes in your book or on the quizzes on Blackboard, instead of using this kind of double bracket, you may see them use like double lines like this. So if you see two sets of vertical lines, this is indicating this greatest integer function. And that may be a little bit easier to write, but if you see that symbol, that means the same thing as this here. So if we're looking at this greatest integer function, if we plug 0 in for x, what does this equal? Well, if you plug 0 in, the way this greatest integer function works, it says that you want to pick, first of all, is the number inside here an integer? Let's start it that way. We have 0 is inside here, which is an integer. If the number that's inside of these brackets is an integer, so one of these numbers up here, that is going to be your answer. So 0's an integer, so this function then is equal to 0. And that's why if we go over here to the graph, that's why when x is 0, right here, y is 0. Now, if I said we want to find f of 1/2, well, that means we're going to plug in 1/2 for x. Well, is 1/2 an integer? Okay, 1/2 is not an integer, so you want to pick the greatest integer that is less than 1/2. Well, if this here is 1/2, then we want to go down below a half to the greatest integer that is less than 1/2. Well, if we go across the number line, the next integer less than a half would be 0, and that's why we have our point here at 1/2 on the x-axis. So therefore, this is also equal to 0. So what do you think would happen if I said f of, let's say, 1.8? Well, is 1.8 an integer? Well, the answer is no. Well, 1.8 would be probably right about here somewhere. So we want to pick, once again, what is the greatest integer that is less than 1.8? Whoops, I'm sorry, 1.8. I meant 1.8. That would be, this is 1, so over here, this would be 1.8 here. So what is the greatest integer less than 1.8? Well, of course, that would be 1. So therefore, that's why our point then is up here at 1. So you're looking at the greatest integer that is less than that number unless the number is an integer. So for example, if I said, what is f of -1? Well, that means you're going to plug -1 in for x. Is -1 an integer? Well, yes, -1 is an integer, so the answer is -1. And that's why here, when x is -1, we go down to -1 for your y value. Now, be careful here. You got to be careful when you look at the negatives. If we had a -1.2, so if we plug a -1.2 in for x, well, first of all, we need to locate a -1.2. So here is a -1.2. Now, now -1.2 is not an integer, so we want to look at what is the integer that is less than a -1.2. Now, this can be a little confusing if you're not careful, because if you go less than -1.2, the next integer would be a -2. Okay, so remember, you're going, if you think of a number line, -2 is less than a -1.2, and that is why at -1.2, then your answer is a -2, which gives you this point here, and that's how this works. And that's why if you were to plug any value, for example, over here, if you plug in a 1, you get out 1. If you plug in anything greater than 1 all the way up to 2, any decimal from 1 to 2 is going to fall right in here. And then that's why when you plug 2 in, 2 is an integer, and that's why that number jumps up to here. And then any decimal from 2 to 3 is going to fall here within this range. So this is your greatest integer function. And again, sometimes this is called a step function, obviously, because it looks like a set of steps. All right, so there's your 8 parent functions. You should make sure that you're familiar with the graph of each one of these. That will certainly make things a lot easier for you. Now, this greatest integer function, I do want to look at how we can enter this into your calculator. If you go to y equals, and we want to look at the greatest integer, then we're going to go to math, and then over to number. And if you look down at number 5 here, number 5 says int, which is your integer, so I'm selecting number 5. And then we're going to select x and close the parentheses. So that means we're looking at this function here, f of x equals this greatest integer of x. So that's with this int parentheses x. We want to close the parentheses. And I'm going to go to zoom standard. And you will notice you have all the little steps here. And to see this a little bit better, I'm going to zoom in a little bit. I'm just going to hit zoom number 2, which is zoom in. And I want to zoom in on the origin, so I'm going to leave my cursor right here in the middle at 0, 0 and hit enter. And that's going to zoom in right on the origin. Now, the one thing your graph really doesn't indicate here, let me copy this and post it over here into the notes. it doesn't really indicate where on my graph up here I put the open and closed circles. And you don't really see the graph right here on the axis, so it should be here going over with an open circle, and then you would have a closed circle here and then an open circle, and then you'd have a closed circle here. So this is where you have to have a little bit of knowledge about this function, because the calculator doesn't show it to you as clearly. Because here, if we want to evaluate this on the calculator, for example, we'll pick an example I did here, like 1.8, we know that should be equal to 1. So here we could simply go to second graph, which is the table. And if you notice here, I already have these numbers entered, 0, 2, 5, 4, 10. Well, all of these are integers, so because they're integers, the function is going to be the exact same number. Now, if I go up here, let's see, if I clear this out, and we want to type in, say, 1.8, and we said the greatest integer less than 1.8 is 1. And that's why if I was to type in even 1.9999, you're still going to get 1. Now, as soon as I type in 2, 2 is an integer, so the answer is going to be 2. But if I was to type in 2.1, we get 2. If I type in 2.2, the answer is 2. Or if I type in 2.8, so anything all the way up to 3 is going to give you an answer of 2, but as soon as you type in 3, 3 is an integer, so your answer is going to be 3. So hopefully if you play with this, you'll get the idea of this greatest integer function. And like I said before, you really need to be careful when you type in a negative. For example, if I type in a negative 2.5, what is your answer going to be? Well, negative 2.5 is not an integer, so we're going to have to pick the integer that is less than a negative 2.5. And if you think of less than a negative 2.5, you're going to the left of a negative 2.5, and you will get an answer of negative 3. And then, of course, if I typed in a negative 2, which is an integer, you would get a negative 2. Now, if you're on if we go second mode or quit to go back to the home screen, you can still type in math and go over to number and down to number 5, which is the integer. And then you could type in any number that you want. So if we want to know, say, 3.725, close the parentheses. Now, this is not an integer, so we know we're going to look at the integer that is less than 3.725, and you should guess this would be 3. So if you hit enter, you get an answer of 3. All right, so there's your parent functions. Again, make sure you go back and review these and you're at least familiar with each function and the graph. Like I said, in the future, we're going to look at how we can kind of move and change these graphs around a little bit. We're going to look at the transformation of the graphs. So make sure you go over the constant function, the identity, absolute value, quadratic, cubic, square root, reciprocal, and your greatest integer function.